Okay, so let's look at this. Oh my goodness, look at all of these different letters. Okay, so dl over dt is kl squared ln of t, and this is the initial condition. So L is like your y, right? T is like your x. And what's this little k thing? Just another constant. Yes, just to be annoying. Okay, so multiply both sides by dt, right? I'm just going to go super slow. If I just multiply both sides by dt and divide both sides by L squared, so I get to this. So k is just a constant, so it can stay on this side here and stay in the numerator, so I'll just leave it like it is. So now here we go. Let's integrate. Integrate. Okay, so I'm going to rewrite this side as L to the negative 2 and keep this side the same. And then to take the antiderivative of ln of t, you need parts, right? So let me show you how you do parts with ln of t. So I'm going to put the k on the outside. So you do u equal ln of t, dv is dt, du is 1 over t, v is t, right? Well, 1 over t dt, right? So then you get uv, so uv t ln of t minus the integral of v du, so t times 1 over t, so you just get 1 dt, so t ln of t, and then this gives me, right, t ln of t minus a t. Okay, that's where all of this comes from, right? And then you keep the k on the outside. And I took the antiderivative of this side. Okay, so I'm going to rewrite this L to the negative 1 as negative 1 over L, like this. This is the easiest place to solve for C, so I'm going to do it. So put in t equal 1. That's what this means, right? Put t equal 1 in here. And then L is negative 1. So negative 1 and negative gives me a positive 1 here. T ln of 1 I know is 0. Here I put t equal 1. I get a negative k plus c. So what does c equal? Oh, c equals 1 plus k. Yep, k is going to be in your answer. So I put in c equal 1 plus k. And remember, we're solving for L. So I'm going to cross multiply, right? Multiply both sides by L and divide by this ugly thing, right? So I keep the negative 1 here. So this whole big thing is in the denominator. Okay, one more. I'm doing lots of these because I think they're hard integrals. So I just want you to have lots of them to have it to access. Okay, so dy over dx, xy, sine of x, y plus 1. So let's multiply both sides by dx first, xy, sine of x, y plus 1. Okay, so keeping the x's by the dx's, so this x and sine of x will stay here. So let's multiply by y plus 1 and divide by y. X sine of x dx. All right, I hear it calling. Integrate me. Here it go. Okay, this side here, parts, you see it, right? U equal x, dv is sine of x dx. du is dx, v is negative cosine, correct? So this right-hand side here turns into uv, so negative x cosine of x, minus the integral of v du. I'll just finish off this right-hand side here. So antiderivative of cosine is just positive sine, and then these two negatives make a positive, so I just get this. Okay. Oh, now what am I going to do on this side? So I'm going to split it around the addition in the numerator. So I get y over y, which is 1, plus 1 over y. Okay, so I'm going to integrate 1 and get y, integrate 1 over y and get ln of y. Okay, looking back, do I have an initial condition? Because I always want to check before I go finish. After I've added the c, I do, right? So this says put in y equal 1. So 1 plus ln of 1 is 0. So let's put it in there for effect. And then put in x is 0. So this gives me 0 plus c. So c is 1. So now I get y plus ln of y equal negative x cosine of x plus sine of x plus 1 for the c. Okay, Look at this. I have y in two different places. It is not possible to solve for y, so I am content to leave it like this. So it is not necessary. It cannot solve for y if y is in two places like this where you can't unnest it.